Good afternoon. This is John Sprovieri, the Chief Editor of Assembly Magazine. Welcome to our latest webinar, Reshoring Consumer Goods with Agile Automation. This event is sponsored by ATS Industrial Automation. Today's presenters are Christopher Spade and Peng Kaw. Chris has spent nearly 18 years developing automation systems. He has overseen hundreds of automated machine configurations, bringing his unique thought process to help customers streamline and move faster. Over the past year, Chris has shifted from engineering and today works directly with customers. Working with clients, Chris brings high-speed assembly and automation know-how to consumer goods manufacturers, helping them find the optimal solution for their business with the most economical cost of ownership. Peng was the CEO and co-founder of Transformix Engineering, an innovator of advanced manufacturing technologies. After selling Transformix's IP to ATS, she spun off Transformix's manufacturing division with 3 former managers to preserve jobs and joined ATS as its VP of Emerging Markets and Symphony. Peng has received many awards, including induction into the Kingston Business Hall of Fame, Women Exporter of the Year, and an honorary diploma from St. Lawrence College. She is a director on several boards. She's a coach, mentor, conference speaker, and has been featured in local and national media. Peng came to Canada with her family as a refugee from Cambodia. Now, this is a live program, folks, so please do submit questions for our speakers. Later in the program, we will address as many as possible. Today's event is being recorded and will be archived on our website, assemblymag.com. And now, without further ado, I'm excited to turn it over to today's presenters, Chris and Peng. Take it away.
Hello, ladies and gentlemen. Welcome, and thank you for taking the time with Chris and I to explore how companies can reshore their assembly process with fast, flexible, and precise digital assembly technologies. By the end of our 60 minutes together, I hope we'll have a strong grasp, not just of reshoring, but the technology that can make it possible. We'll talk about why consumer packaged goods industry must turn to agile solutions to satisfy an increasing complicated supply and demand landscape. Leverage assembly asset to shorten time to market. Utilize digital technology to allow for high-speed production of multiple products and just-in-time delivery. Finding the right automation partners to reduce risk. I've been in the automation industry for over 27 years. As John mentioned earlier, I founded an automation company in 1995 with 3 engineers. And because of the length of time that I've been building continuous motion and indexing motion machines, I spent a lot of time thinking about the big ideas of manufacturing, the larger forces at play, and the future of our industry. Now more than ever, that future is filled with uncertainty and instability, and businesses are forced to adapt to survive and thrive. Next slide. If we take a wide view for a moment, the last 2 decades have seen the rise. Sorry, Vanessa.
What?
Back.
Oh.
If we take a wide view for a moment, the last 2 decades have seen the rise of e-commerce, rapidly evolving consumer behavior, climate change, political upheaval, the Internet of Things, the rise of China, a historically unique macroeconomic environment for inflation and interest rates, and of course, the relentless march of automation across every industry. All of these questions are in search of answers, and businesses must respond whether they're equipped or not. The COVID pandemic has merely accelerated trends that were already in motion for many years. Likewise, the geopolitical earthquake that has been on everyone's mind, Russia invasion of Ukraine, exacerbated our supply chain issues. It is hard to deny that both slowly and suddenly the world has changed, and with it, how we do business. The number you see here the numbers you see on this slide are from McKinsey and Company report, which shows the vulnerability of global supply chain, not just to COVID, but to the other shocks that I just mentioned. In the first year of COVID alone, US and European companies lost up to $4 trillion in revenue to supply chain problems. No one could have predicted this in 2019. Now that we have experienced the weaknesses in our global supply chain, companies and governments see COVID as an accelerator, not a blip. These disruptions will ebb and flow over the coming decades, but they will not disappear. Some of these we can predict and plan for, others we can't. So we're going to do a quick poll right now to see how the supply chain has affected your organization. We'll give you about 15 to 20 seconds to do the poll. Great, so the results are coming in. Wow, so I think it's just coming in right now.
Yeah.
All right, thank you. Next slide.
Okay.
Even though we are in a very different place with COVID than when this survey was taken in May 2020, we can see that respondents were accurate in how they believed things would unfold. Specifically, the biggest predicted trend in that survey is the adoption of automation technologies to build resiliency and agility to adapt to rapid changes. Manufacturing is not returning to the old ways. We have moved beyond assembly line dedicated to producing singular products or offshore to cheap labor countries. Businesses that depend on supply chains crossing international borders are more vulnerable to economic, financial, ecological, political, and geopolitical shocks as we are currently seeing right now. The obvious answer then is to reverse offshoring. Even before the current crisis, reshoring was becoming more attractive in the last 10 years. Especially with the rise of China, which benefits so greatly from our offshoring over the past 35 years, has naturally resulted in much higher costs in that country as their middle income continues to rise. It's a little bit more complicated than a simple pendulum of labor costs swinging back and forth, because there's always somewhere that is nominally cheaper. The more profound global change that makes reshoring possible is the revolution in automation technology that we will discuss today. The kind of automation that I'm talking about is digital, standardized, modular, scalable, and configurable. As opposed to conventional assembly machines, which are custom designed and built for one purpose, agile automation solutions more closely resemble the evolution of computers. They are more and more flexible, capable of a wider variety of tasks, but not at the expense of speed or performance. They utilize the Internet of Things and are easy and quickly deployed. Additionally, like the computers, they have to be cost-effective and user-friendly to operate and maintain. High throughput, high asset utilization, high speed, high flexibility, scalability, and adaptability. These are the hallmarks of automation that is transforming assembly technologies. Custom assembly automation is complex and risky and expensive. The conventional wisdom is that you must choose between slow but flexible, like pallets and robots, or fast but inflexible, like continuous motion. My team and I spend years trying to find a way out of this conundrum. Because of it, we called assembly the problem child of automation. We needed a way to transform that problem child into a model citizen. If you're interested, I wrote 3 blogs on this particular issue. You can find all 3 blogs in our website at symphonytech.com. In 2012, one of my former clients was fed up with having to choose and asked if we could make a slight innovation to continuous motions that they've been buying for the last 35 years. So we set to work. We wanted to challenge the paradigm and develop a high-performance solution that is also flexible. With Symphony, we achieved high speed and deliver versatility without sacrificing precision and gentle parts handling. At the core of ATS patented Symphony system is our RSM technologies, a remarkable innovation that permits maximum efficiency in transferring parts and work in process. Because it functions as a distributed N-axis robots, precisely coordinating and synchronizing all system motions with electronic gearing, Symphony offers features and benefits that are unmatched by traditional assembly technologies. The 3 key features of Symphony are 1, standardization and modularity. Symphony systems are composed of standard self-contained modules that operate independently but tightly integrated entities. Each module has the same control panel, as you can see here. They has the same control architecture and run the same proprietary software. Just so you know, this is I wasn't allowed to bring a whole Symphony system in place. I'm just joking, obviously, but I wanted to have a miniature Symphony to show you what it actually looks like. Because of its digital nature and high level of standardization, Symphony reduced the cost of spare parts, maintenance, and training. 2, the second feature is flexibility, scalability, and configurability. Symphony systems are capable of adapting to a wide range of different products, permitting multiple products to run on the same production assets with 0 to minimum changeover. Symphony system can be repeatedly retooled and reconfigured for new application, serving as depreciable assets, analogous to machining centers and injection molding press. So think about it. Every Symphony machines, no matter how many different components it does, look very similar. The only difference that you will see as you visit our YouTube or website is really the length of the machine. It could be with 4 modules or even 2, or it could be 8 module, or in this case, 6 module, let's say, 3 on the left and 3 on the right. So every Symphony machine is configured from standard building block. It is not custom designed or custom built. Symphony, therefore, decrease risk associated with product launch and buying new equipment, and thus shorten your time to market. The third features of Symphony is that it's high output and high efficiency. Symphony features continuous flow processing, maximizing operational efficiency and minimizing value-added losses. In essence, Symphony embodies lean manufacturing principles inside the machine, delivering high speed, yet is flexible and gentle on parts. That's always been one of the misconceptions when people see a Symphony machine running. It is so fast, they just assume that it's damaging the part. It's not. And we're going to talk a little bit about more in the operating system. The clients who asked in 2012 to implement a slight innovation spurred on a technological leap. That's why, after purchasing 16 machines, they proclaimed Symphony the most significant development in automated assembly in 40 years. In 2016, a trade magazine called Symphony the Holy Grail of assembly automation. Next slide. So let's touch on the operating system. Symphony operating system is simple, standard, and embedded. Each module runs the same software, has the same control panel. It is extremely efficient because each module only has one critical process and only execute that process when the control panel directed to do so. The control panel synchronizes all functions in 1 millisecond. It tells the system to go as fast as it can for non-critical process like parts movement from station to station. It gives each module the time it needs, so we respect the critical time to execute the critical process, like insertion, like ultrasonic welding, like gluing, whatever the case may be. So you think of a Symphony machine like an orchestra, then the control module is the conductor. Each of these middle modules are like an instrument, a piano, a violin, drum. They can all run on its own, which we'll touch on later. But when they come together to form a fully automated piece of equipment, it produces a beautiful symphony of motions. And I invite you to visit our YouTube website, which is also Symphony Tech. And there's lots of great videos in there that further explain. And there's a 360-degree virtual machine tour in there as well. So let's touch on the mechanical building blocks of Symphony for a bit. Because Symphony is fast and flexible, it is a general purpose asset that can run 24/7 to assemble multiple products on the same shift. Symphony offers the lowest total cost of ownership, while dramatically reduces the risk when buying new equipment. Symphony plug-and-play building block, so this is what we call our RSM. Think of it like a N-axis robot. So unlike robotic arm where you have to buy 2-axis or 5-axis or whatever the case may be, this is N-axis because it's all digital, it's programmed. This is what we call our RSM disc. And RSM, which is the technology I mentioned earlier, stands for rapid speed matching. So every one of these building blocks are built to inventory. They are pre-tested, pre-validated, which means that even before we receive a purchase order from our customer, 90% of the machine is built, tested, and validated. This allows ATS to be ahead of the curve in dealing with supply chain issues. This also allows you, Mr. Customer, to mitigate the risk when you're buying new equipment. There are no custom PLC codes in Symphony. The control is configured from pre-programmed, pre-tested, and pre-validated apps. All changes that needs to be done, so let's say in the future you want to configure this differently, or you want to change the tools, right? Touch tooling for a different process. All of that can be done via the HMI. Not so good at the Lego part of it. So one of my former customer who bought a lot of machines actually developed recipes. So they use the HMI to create recipes for each of the injection molding machine. And the reason they do that, as you know, plastic always has slight character change depending on which injection molding machine produced them. So knowing that, they create recipe to optimize their OEE. The high level of standardization removes not only delivery risk that I talked about earlier, but also technological risk. Because of its digital nature, not only is Symphony easy to train, operate, and maintain, its annual spare is 80% lower than traditional equipment. A Symphony machine runs continuous motion rate with 90% less mechanical tool to maintain and replace. A former client is currently producing 100 million caps per year. Their spare part cost is less than 1%. And that's over the last 5 years. The average spare cost for a custom built assembly equipment is 3 to 5% per year per machine. Symphony is scalability is one of Symphony's key advantages. Imagine your product team is developing a new pump. Traditionally, during the prototype stage, the pump are hand assembled. Once sales pick up, you move to a semi-automated machine. As sales continue to grow, you're ready to order a fully automated equipment. From your experience, you know you must buy a machine with production capacity that can meet the highest project sales. All these stages and the transition between them takes time and money. Frankly, it's a waste. And that is the best case scenario. Sorry, I missed a poll. So we'll let you do a poll again. How often do you need to change or introduce a new SKU? And we'll give you 10 seconds to do this. Okay, let's go on.
33%.
So we're talking about scalability, and I brought up an example of the way assembly equipment are purchased in the traditional way. And we talked about the best case scenario is if your equipment builder build a machine that's delivered on time. But what happens if your machine builder is late with your equipment and you miss your product launch date? Or what if the new product does not take off after it launched? Or what about those wasted machine utilization or capacity during the early and late stage of your product lifecycle? With Symphony, you can start with a single module that we call a Sonata to prove production process during R&D. Continue to use that Sonata for market testing. As sales grow, simply add additional module for a semi-automated solution. Finally, these modules can then be configured into a full automation machine. During the early stage and late stage of the product lifecycle, add new tools for new products or new process. This optimizes your machine utilization throughout the life of the machine. If your new product is not successful, you can retool, reconfigure, scale up, scale down for a different product or process, which is exactly what happened to a customer of mine. After they launched their product, they came back a year later and asked if we could design a new tool for a new product that they want to put on. For 2% of the base price machine, they were able to retool the equipment for a different product. With Symphony, your investment don't get wasted. Your machine does not sit idle. Additionally, when you invest in an agile assembly technology, it can be part of your corporate sustainability strategy. To sum up, Symphony offers 3 key advantages. The first one, ensure your product development process, including manufacturing, validation, and approval, thus improving time to market. 2, it lowers your capital costs by leveraging investment from development to production. Eliminate duplication while maximizing your asset utilization. In 2017, we had a client who wanted to reshore production to the US. They had bought many indexing motions and continuous motion machines from my former company. We convinced them to consolidate several of those machines so that they would not have to expand their factory. In that scenario, which is exactly what they did, comparing the price of a Symphony machine to a conventional assembly equipment is like comparing apples to oranges. You just don't. The third advantage, Symphony reduced the cost per part by lowering your labor, operating, and maintenance expenses. Again, think of the evolution of computer and mobile phones. Assembly automation is moving in the same direction, and Symphony is a tip of the spear. How can you reshore your operation without dramatically increasing your production and capital costs? The answer is Symphony. Because of the financial benefits that the technology provides, reshoring becomes not only feasible, but obvious. Next slide. We have another poll for you. We'll give you another 10 seconds to do the poll. Quality is most important. 70% agreement on quality. Okay, so manufacturers across North America and Europe see the writing on the wall with geopolitical instability, economic uncertainty, climate change, and rapidly changing consumer behavior. They need to adapt to these circumstances by turning to strategies of resilience and adaptability. Increasingly, this means reshoring their production. But while it may be a buzzword in the political circle, we know that reshoring is only viable and sustainable if companies also adopt high-performance, agile digital technologies. What product and process could Symphony do for you? What doors can it open for your business? What opportunities are baked into the technology that we haven't considered yet? I'd love to hear from you. In the meantime, my colleague Chris would discuss a few case studies that highlight how Symphony has helped ATS customers. Chris, over to you.
Great, thank you, Peng. So yeah, as Peng mentioned, we're going to take the presentation towards some case studies, some examples that really exemplify a lot of the points that Peng was bringing up in the earlier part of the presentation. First, just a little bit about myself. So Chris Spade, sales manager, as John mentioned. However, most of my career here with ATS, nearly 20 years, has been with applications engineering. And what that is, for anybody who doesn't know, it's basically taking customers' manufacturing needs and figuring out what automation platform is best for those and providing a solution for their manufacturing needs. And it's from that perspective that I can say that this really is a transformative assembly platform. It's really for high volume CPG, it's absolutely the best tool in our kit. So we'll get on to the first case study. Oh, sorry, I don't. There we go. So this system here, in process of build right now, this was born out of the COVID crisis. And the related demand for sanitizing products, such as now I have some samples, some products here that I'm going to hold up. I'm not endorsing any particular products, just some good examples of things for Symphony. So sanitizing products such as this pump for hand sanitizer. So this was a US-based company that was sourcing all of their components, all of their subcomponents, and most of their assembly from low-cost countries in Asia. So if you remember at the start of the pandemic, which seems like many years ago, Asian countries were probably 3, 4, 5 months ahead of North America in as far as the curve of cases go. So when it got to the point where demand started increasing for such products like these hand sanitizer pumps, demand was already soaring in Asia, and there was just the supply was cut off. So our customer here in North America could not get components to sell things like sanitizer pumps here. So this event is what drove their decision to set a course for manufacturing locally. So when you do that, when you move from a low-cost country at such volume, such as Peng mentioned, over 100 million components a year, if moving from a low-cost country to a higher-cost area, you have to use automation. And really, you have a few choices when you're going that fast. It's either continuous motion, which is the traditional answer. You have discrete automation like robots and pallets that Peng mentioned. We answered this particular case with Symphony, and we performed an internal comparison of discrete automation versus Symphony. And I can tell you that the layout, the floor space required, was 1/3 of the standard automation solution. So the Symphony platform was 1/3 the size. It also was lower cost compared to that discrete automation system. Now, our competitor, our competition in this particular case was proposing a continuous motion solution, and the Symphony solution was roughly half the size, utilized far fewer people, and had a much lower projected maintenance cost, as Peng was mentioning with the example she pointed out, with a 1% of the program. So fabulous example there, and I want to just hit some highlights of that system again. Some points here. It was a 300 part per minute system, which translates to over 100 million parts per year. This included functional testing, so flow and pressure at these rates. Another benefit to the Symphony system versus the continuous motion system: far fewer testers required to perform these tests. We also have the ability, based on the digital nature of the machine, to use multiple nests within the same pallet. So this allows us to keep all of the assembly operations on one machine rather than having to do some here and then transfer over to another machine and do the rest of the process. Lots of testing and verification going on the machine. Again, 50% reduction in floor space, significant reduction in test time, all work done on one machine. And of course, with a lot of consumer products, you have seasonal variations, different colors, different shapes, different decorations that might show up on the part from season to season. That kind of verification is very easy to apply and is often already integrated into the Symphony system. So I'll move on to the next case study here. I do have a video of this system, but before we launch the video, I'll give you a little bit insight here. So this was another interesting COVID-related system that I'll get into that aspect of it here in a moment. But what's great about this video is it shows some really good footage of the critical components of the Symphony system that Peng was mentioning. So such as the RSM, or the Rapid Speed Matching Assembly. It looks a lot like a continuous motion component. It's kind of how it came to be. However, we've taken away some of the issues that are related to continuous motion, in particular, the scraping of parts against guides during the assembly process. So something that's nice and shiny like this lip gloss here would be damaged or have the potential to leave witness marks on those decorative caps. We've eliminated that issue with Symphony by drawing parts into the RSM and holding them securely and getting them into the assembly process without scraping them along guides and such. So I'm going to play the video here. I believe there's some music on this one, so I'm not going to talk over the music. Once that video is complete, I'll give you a little bit of insight, the interesting story behind this system as it relates to COVID. Great. So as you, excuse me, as you saw there, what we often do for demo systems like this or for videos is we'll run the system at at its normal production rate and then slow it down so that you can really see what's happening. So we have that capability to basically it's electronically cammed, so we can slow down that heartbeat of the system to show what's going on, because they're often going so fast you can't really tell. It's faster than you can follow. But as the system relates to COVID, this is a plunger assembly for a syringe that was used for vaccine delivery. And if you can go back a year or so to the early days of vaccine deployment, vaccine production was still rather limited, and maximizing what could be produced was very critical. So this particular syringe has less waste than a traditional syringe. So there's some inherent dead space in most syringes. This one had much less. So it actually resulted in being able to get one more dose out of each vaccine vial, which really helped expand the vaccine deployment. So again, being COVID related and vaccine related, delivery or time to production was very critical. This system was actually able to provide plungers to our downstream automation. So we had more equipment that was downstream of this particular station in 20 weeks after launch. And that's possible because of, like Peng was saying, the modular and standard nature of the Symphony system. Some fast facts here again about that system: 360 parts per minute, 3 times the speed of the machines that were making a very similar product to this. And this very nice figure here, our machine OEE at SAT or site acceptance testing was 98.55%. So again, the benefits: rapid deployment. This is, of course, a reconfigurable asset. So knowing that this might be a temporary deployment, our customer knows that they can easily retool this system for other products if needed. There's also 50% reduction in floor space compared to a traditional automation solution to this assembly process. So I'll go on to the next system here. This one, we have a video of this one as well. So this is a good one that shows how well we have control of the system, of the motions of the system. Peng alluded to, it looks like we're just really slamming these parts together and we're very rough with them, but that's absolutely not the case. So this video is of what we call a proof of principle test, or a POP, where we basically test a critical operation or a critical assembly process step. So that is absolutely the case here. This is a glass a glass syringe that's being installed into an auto injector. So if you a pre-filled syringe. So think like EpiPen or the Narcan type injectors. That's what's going on here. So the pre-filled glass syringe is of course full of a sterile liquid, and if you do not if you insert that glass syringe body into the auto injector too rough, too fast, too forcefully, you can basically dislodge the stopper, or I'm using a very simple term there, and risk breaking sterility. And that's, of course, a critical failure. So we cannot deviate from that established, validated process. So to do this at rate, traditional automation, our competition in this particular case, needed 40 tooling nests to accomplish this process. That's 40 tooling nests. And we did it with 4 nests. And I'll play the video here, and you can see first a high-speed version of it. This is only one up tool because we were just testing. Here's a slow motion view of that same test. And this being the critical process here, where we're inserting the body into the auto injector. I think our video might have stalled there, but again, so the competition required 40 nests to accomplish this process, and we did it with 4. Now, we absolutely did not alter the insertion timing, the insertion speed, and the insertion forces that were required here. That was just a no-go. So how did we get done with 4 nests? What our competition was using 40 is really a study in lean manufacturing. So many of you are probably aware of MUDA, Japanese term for waste. There's necessary waste and unnecessary waste. In this case, if you look at this process step on a very microscopic view here, the only value add step here is the actual insertion of the syringe, the glass syringe into the auto injector. Everything else is waste. So we can't eliminate the pick and place motion of going back and grabbing the syringe body and bringing it forward and ready to insert, but we can reduce that. And we do that by just going as fast as possible during non-critical portions, and then slowing down and carefully accomplishing the critical value add portions. And that is what we did here. And the result being almost 70% of the cycle time was dedicated to that critical process step, and 40%, nearly 40% was the pick and place motions of moving away from the part and bringing it back. Because of the way we do this assembly process, we actually eliminated the pre-insertion quality inspection and the post-insertion quality inspection and integrated those into the system. Those quality checks were just done with the Symphony tooling. Again, 40 tools versus our 4 tools at 320 parts a minute. 80% reduction in floor space because of the number of tools required, and 90% less tooling with our system versus the traditional automation. So our last case study here, I find this one's very interesting. And you notice the machine markings. This is a Transformix machine under the CNC Assembly brand. So not only does this machine tick a lot of the boxes that Peng was speaking about earlier, which I'll expand on in a moment, but it really shows that, while this is a new technology for ATS, it's been in development for over 10 years with the Transformix team. And those key individuals that developed the Transformix CNC assembly system are now part of ATS. Peng and the engineers she spoke of earlier, they're part of the ATS team that's working on pushing Symphony to the next level of modularity, redeployability, and flexibility. So I'll start this video here, and you can see the assembly process. So this is a connector assembly that had quite a few different variants and was actually manufactured on several different machines. at a much lower rate. So several machines at a much slower rate were consolidated to one machine at, of course, this very high rate. Now moving to this chassis permitted the customer to consolidate to one machine, obviously, less tooling, far less personnel, and takes up a lot less floor space, which is what prevented them from needing to expand their facilities. All right, just some quick facts about this system. Excuse me, 250 parts per minute. It was 9 machines that were previously manufacturing these, and over 20 variants. 5 pieces were in this assembly process, which included some driving of screws. 90% labor savings, 80% reduction in floor space, absolute increase in asset utilization. If you have 20 variants of a product that you're making over 9 machines, those 9 machines are often not running at the same time. This was really fully utilized, this piece of assembly automation. So that was our last case study. I want to move on now to what types of products are a good fit for Symphony. So what's really an ideal fit? So really what we're looking for here is it's a series of inserting, stacking, with either light press fit or no press fit, threading components together. Radial orientation really is not a problem, even if there's no external features to orient with, which that is a real problem for continuous motion systems, which really rely on external features to orient components prior to assembly. Really any shapes work here. Springs, screws, lubricants, adhesives, not a problem. Testing, which is it's a long-term strong suit for ATS, is almost always incorporated on these Symphony systems. It's really not an issue to do, and we have a lot of cool tricks that we can do with the Symphony system to reduce the number of testers, whatever method that is, to save on the overall capex. The size of the component should be roughly handheld. I guess that's pretty full definition there. If you can hold it in your hand, it's probably about the right size for Symphony. Production volumes, 40 parts per minute to over 1,000 parts per minute, which translates to maybe 15 million per year, up to 500 million per year or more, if you're running 24/7 with a couple of shutdown weeks. And the number of components, 2 or more, really. Really, there's not an upper limit. I'd say maybe a dozen or more per chassis, and we can easily link chassis together to do larger assemblies. So I hope this gives you a little bit of context. I have just a couple of pictures here that might trigger some thoughts of types of components that would be a good fit for the Symphony system. But yeah, I hope this provides some good context for you, and I'll hand it back over to Peng to wrap up before we take your questions.
Yeah, go ahead. So thank you, Chris. And I'll just wrap it up quickly to optimize the time for questions. I think everyone gets it now. Symphony is a digital assembly platform that offers the benefits of conventional assembly technologies. It has been transforming the CPG industry in how companies buy or invest in their assembly equipment since 2012. It has helped companies with their reshoring, as the case I mentioned earlier. Our question to you is, are you ready to join them? We're open for questions, and at the end, I will provide Chris and my contact information in case you have additional questions. We're open for questions.
All right. Thanks, folks. Before we do take questions, I would just like to ask everyone to take a minute or two right after the webinar to take a short survey. Your comments will help us serve you better. We want to give you what you need. So first question here. How hard is it to switch to a new tool?
I can take that one. It's actually not difficult at all. It depends on the size, the diameter, the physics of the product that you have. We've had clients that we trained them on how to design touch toolings, and it's the technology is designed for quick disconnect. And the clients, the project that Chris showed in his fourth case studies, in that particular case, the spec calls for a 5 minutes changeover on the touch tooling. Now, in that particular case, there were 5 big bowl feeders, and a certain family, a certain SKU does not require the bowl feeders to change, and others it does. So when you have to change the bowl feeders, then it really depends on your operators how fast they can change. But the touch tooling itself, that has to be changed on the either the RSM disc or the RSM arm, it's less than 5 minutes.
Wow. Okay.
Do you have anything to add?
Yeah, sure. Yeah, I can expand on that a little bit. So we can, if you have perhaps like 2 high runners and then a few other different models that you run, we can configure the system so that we can prioritize those 2 and make the system so that it's no changeover, perhaps with if there's a large variant in one of the parts or one of the components, we could actually have a bowl on the system to feed both of those different components, or 2 separate bowls to feed those components. Otherwise, like Peng said, or we've said throughout the presentation, the number of tools on this system is far less than a continuous motion system. So 4 pick and place grippers versus a drum that might have 14, 20, or 26 tools on it to guide a component on.
And if I can just add maybe one more story, I have a former client in Europe. They actually had the machine. So when we started the project with them, it was for 2 high runner products. And so they had the machine running clockwise for one product and counterclockwise for a second product, because the physics of the parts are very similar, but the process was different. And when they were doing FAT, they actually asked us to do a third part, and we actually did run a third part on the same feeder. So really depends on what you're looking to do.
Huh.
Next question, John.
That's interesting. Okay, yeah. Well, since you've been talking about variants, what sort of variations can be done on this system?
So I can give you an example. Again, this is a real live example. When my former company Transformix was winding down, we actually had a project that at that time we were in, developing what I call the Gen 5, which is this modular configurability that you're seeing in the miniature model here. And the machine was designed and built for a automotive customer. COVID hit, they didn't want the machine anymore, and I was winding down the company and to join ATS, and ATS asked us to negotiate and actually buy the machine back from the customer, and that machine in 14 weeks was reconfigured, retooled to run a medical device product. That's 14 weeks with 5 engineers. So, those are the kind of variations that a Symphony can handle, from automotive components to medical device and everything in between.
Huh. Very cool. All right. Well, here's a question. If we implemented this system today, how long would it take to shift production from Asia back here to North America?
Chris, do you want to take that one?
Sure. Yeah. There's loads of variables in there, depending on what the components look like, what the feed systems would be. I don't really want to throw a number at that without seeing the details. I still am an engineer at heart, so we'd be happy to take a look at it. but it really depends if we're talking something that's a dozen components with lots of testing versus a 2-component closure or something like that.
Mm-hmm.
Well, I think one of the things that we can maybe give you a live example is even now when we're just building up inventories, as I was talking about earlier, we are able to quote these machines to deliver in less than 40 weeks. Our competitors are quoting over 60 weeks. So, and what we're trying to get to is half of that. So we're going to get there. It's just not today. And then, of course, to Chris' point, how fast can you reshore? Well, it depends on all your other operations.
Absolutely. That's a very good point, and something we've witnessed, that the machine has been often waiting on parts because getting new molds made, getting mold machines in-house, getting parts redesigned to be molded locally, it takes some time. And of course, these machines running at these rates, they eat a lot of parts. So we need a lot of parts to get the system up and running.
Sure. Okay. All right. Question of my own, if you don't mind here. You threw out a term, Chris, electronic camming. Mm-hmm. Can you explain that to folks who may not be familiar with that term? What does that mean?
Sure. Yeah, and actually, Ping had a slide on this was showing an orchestra or a symphony. So basically, the one end of the system, is the control end of the system, is the conductor. And it's the heartbeat of the system. If you imagine, to take this back to a real cam-driven system, you'd have a one shaft running down the center of the machine with a bunch of cam lobes on it. And as that shaft rotates, that controls all of the motions of the rest of the machine. In this case, there is no shaft. It's all electronic. So each one of the Symphony modules, if you pick up one of the modules, each one of those modules has its own processor on board that's scanning at millisecond level and following that conductor at the one end of the machine. So that's the synchronization of the system, and that's the electronic camming that we do.
Okay.
I feel like Vanna White, Chris. But Chris is absolutely right. Every single module has its own control. This is why it can start off with just a single module, as we call Sonata, to run, lower volume, let's say, for R&D purpose or just for market research.
Right. All right. I think we have time for one more. I couldn't help notice that ATS's SuperTrack system was involved in many of those videos that you showed of the case studies. That must have been a really nice dovetailing of the Transformix technology with the SuperTrack.
Yeah, John, absolutely. These linear motion technologies are wonderful in terms of it allowing us to transport the parts from the different zone. And my analogy always is that although the linear motion technology, whether it's SuperTrack or iTrack, if it's paired with off-the-shelf robotic system, it can only go as fast as the slowest piece, whatever that may be. It's different than, let's say, a relay competition where, the team could be fast, but they're slow by the slowest person. But when it pairs with the Symphony technology, where the motion is all synchronized, that's what allows it to have that high speed. And my analogy is, this that we used to talk about, we call the Superman story. And that's if you're in a platform and if you're in a high-speed train and I'm on a platform and you're coming at full speed, I'm watching the train comes and I pick up speed, and at relative speed, I'm flying with the speed of the train, and I slowly hand the bottle of water to you as the critical process. And so having the SuperTrack in the middle paired with Symphony is allow us to have the high performance and the high speed that makes this possible.
Yeah, and I'll add that Absolutely, yeah. The way that the ATS SuperTrack system is configured, basically its core design, is what's really helping Symphony move to a modular system in the way that Peng has described, with the being able to run a Sonata on its own. Each SuperTrack system is controlled locally, so being able to swap out modules potentially when you reconfigure a system, or grow and add modules as you go, is really inherent with the moving to SuperTrack with the Symphony system.
Okay. Well, gosh, that was a really fast hour. That is all the time we have for questions today. Please join me in thanking Chris and Peng for their presentation, as well as our sponsor, ATS. If you have additional questions or comments, please click the Email Us button on the console. And please visit webinars.assemblymag.com to view the recording of this presentation and to register for our upcoming events. We've got webinars coming up on safety, press fit assembly, machine vision, and control panel design. So I think you're going to want to check those out. Until next time, keep after it.
Thank you.